Okay, good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
So today we will study the last topic of the statistics part, and that is the moments. So moments in statistical terms is again a type of deviations from different values. Okay, and from different values we are finding out the deviations, and not just the deviation raised to 1, but the variation is deviation raised to the power 1, deviation raised to the power 2, deviation raised to the power 3, and so on. So what is it used for? So first of all we will actually see, okay, what is the objective behind learning this, uh, what we call the moments. So objectives are, they give the tools for comparison of the data. Okay. Uh, so objective is tool to compare data. So we'll be able to compare the data sets, and in what terms we are going to compare. So I'll draw two diagrams here, and we'll study what is happening. Yes. Any remarks on this? Or any observation? The left hand side curve, the right hand side curve. First of all, what will be the mean for the first data?
It would be equal to around the middle value.
Middle value. So these are the observations. First of all, let me just clear. These are the observations. Okay. So your observations are between these 2 points. Now, when we talk about the mean of this data, it will be at the center of this observation. So must be somewhere here. Where will be the mode?
Around that point.
Around that point itself. Okay, so I'll consider the same point. What about the median?
Same.
Same. So what happens in the first cases? Mean is becoming mode, is also becoming the median, because we can see that the data is distributed uniformly around this value. Okay, so the highest frequency is this, and in the second one, what will happen to the mean? What will be the relation actually? Say, I'll just talk about mean and mode. What will happen here?
So mode will be greater than mean.
Mode will be greater than mean. Okay. So the mean will be on the left hand side, right? So here we will. This is going to be the mode, and the mean actually is the midpoint of this observation. So it will be somewhere here. Like mean is going to be here. All right, and mode will be somewhere around this. Okay. So why is this happening?
So it's not distributed uniformly. That's why.
So the curve, as you see, it is stretched on the left hand side. So this criteria is this shifting of the curve, or that wherever it is shifted, either it is shifted on the left or it is shifted on the right, it is actually called the skewness. Okay, so skewness of a data can be studied using the moment. So doing mathematical calculations, you would be actually able to tell whether the curve is shifted on the left, or it is shifted, or the data is shifted on the left, or it is shifted on the right. Moreover, one more important thing here is that I can study this. I'll draw another diagram here now. Yes, what is the difference between three of them?
The frequencies.
Only the frequencies? Sakshi? Ritika? Left. Saurabh?
Yes, sir.
Yes, what do you observe? What is the difference between the three diagrams?
Between among these three diagrams, I think each each will be same, like mean, mode, and median for all these three diagrams.
Okay, what is the difference? What is the difference between the three diagrams? What is going to be different?
Mm, First will be the frequency, and then
Hasnain?
So since the curve is means the amplitude is high in the first one and then decreasing.
Range
Uh,
of the frequency.
Range of the frequency, of course, it is. Yes, it is correct. So, in statistical terms, what we call is, what we are looking at is the peakedness of the curve, and in statistics, this peakedness of the curve. In the first curve, you have the peak. In the second one, it is, I mean, you are not getting a peak. And third one is almost plane. Okay. So this criteria that we are studying in statistics is called the kurtosis. So this is called the leptokurtic, this is the mesokurtic, and this type of data is called the plateaukurtic. So it is almost plane. There is no peak here. In the first one, there is we are getting a peak, and that is the leptokurtic, and this is the mesokurtic. You cannot say that there is a peak, or it's almost plane. So this is called the mesokurtic. So moments are usually used to compare the data, and how it compares the data. It compares the data by skewness or by the kurtosis. This is the objective behind learning this moments. So the first type of moment that we will see is the moments about mean. So we'll first of all write down the definition. Moments about mean.
Sir, I have a question.
Yes.
Sir, are the width of the all of those graphs same?
Width, of course, I mean, in same condition, in this condition, we'll consider the same, but it will, of course, depend on the data that we have.
Okay, sir. So how range is different in all of these?
What is range? Range is actually, yeah, someone said it, there is a difference in the range, but he talked in terms of the frequency. The range, of course, we talk in terms of x, but he was talking in terms of the frequency.
So basically, it is frequency only.
No, it's not frequency. It is the combination of the variable and the frequency.
Oh, okay, sir.
Yes, what we were doing was we were writing the definition for the moments about the mean. It is also called as the central moment. Why it is called the central moment? Because the moment is calculated over the mean. So the central moment of order r in bracket is also called the rth moment about mean is denoted by mu r and is defined as mu r is equal to summation xi minus x bar raised to r. I is running from 1 to n upon n. This will be the formula for the raw data, right? If there is a frequency distribution, then can you modify the formula? Yes.
Submission Fi xi minus x bar whole like bracket r
Yes.
upon submission Fi.
So,
I is running from 1 to n.
So the formula will be summation fi xi minus x bar raised to r. I is running from 1 to n upon summation fi. So for frequency distribution, so you should be able to now make any of the formula using the raw data. I mean, you should be able to extend your formula for the raw data to the frequency distribution. And if you have the formula for frequency distribution, you should be able to go back to the raw data formula. Can someone tell me, can you obtain the raw data formula for the frequency distribution? How can you do that? What is the difference? I mean, think over it. I'll write down the particular cases by then. Yes, can anyone tell me what is mu1? What will be mu1 here? summation
xi minus x bar by n.
xi minus x bar, I is running from 1 to n divided by n. Can you simplify this and tell me what will be the value? Can you simplify this?
Sir, I actually don't remember the formulas.
Okay. Anyone else who can simplify this and tell me what will be mu1?
Sir, to simplify, I think we can write mu1 is equal to summation xi upon n minus summation x bar upon n.
So what will be the value then?
Mm.
X bar minus X bar by n.
X bar minus x bar.
By n.
So the answer is
Wait, no.
0.
0. Exactly. Just one thing that you missed is that summation xi by n will be the first term, minus x bar is of course a constant, so will come outside, summation 1 upon n. I is running from 1 to n. So this 2 will get cancelled out and this term is x bar. So this and this will get cancelled out and the answer mu1. So first central moment is always 0. Okay, always 0. What about mu2? Anyone, what is mu2? Look, what we have written is true for raw data as well as the frequency distribution. Now, mu2.
The mu2 will be variance.
Exactly, very good. So mu2, the formula will be summation I is running from 1 to n xi minus x bar square divided by n. This is the same formula which was for the variance, sigma square. So mu2 is variance. So generally, why I'm writing this is because generally we will use the first 4 moments. We won't go for the 5th, 6th, 7th, 8th or anything like that. I'm writing this because we need only first 3 moments. So mu3 will be summation I is running from 1 to n xi minus x bar raised to 3 upon n. Now, this cannot be simplified. This we will have to calculate for a particular example. Similarly, mu4 summation xi minus x bar raised to 4. I is running from 1 to n upon n. So these two formulas are for raw data. The same thing can be written for frequency distribution. So mu3 will be mu4 is equal to summation xi minus x bar fi raised to 4 upon summation fi. These simple changes you can always do, right? So these are the first 4 moments. In the similar manner, what we can write down is the moments what we have calculated about the mean, the same moments can be calculated about any of the values. Okay, so by any of the value I mean say in some data I feel that I need to find out the moments about 50. Okay, so the same thing can be done. Okay, so such moments are called the moments about A.
Sir,
Yes.
for 1 minute, can you show that formula for mu r for raw data? mu4, sir, it's down.
Okay, you want to say mu4.
Yes, sir, you can.
So moments about A.
Done, sir.
So this A is also called as the assumed mean. Okay. So I am assuming that, I mean, so okay, suppose A is a mean and I am doing the calculations. Okay. So this is also called as the moments about the assumed mean. So moments about A are are denoted by mu r of A, and is defined as, yes, anyone who can guess?
Summation xi minus a
Xi minus A
raised to
raised to R.
r. Yes.
Exactly. So the raw data summation xi minus A raised to R, I is running from 1 to n divided by n. The same formula for the same in frequency distribution, Fi xi minus A raised to R, I is running from 1 to n summation Fi, I is running from 1 to n. This is for the frequency distribution. This is for the raw data. Okay. Why are these important? Once again, the importance is that whenever the data is large or the values are large, so just the way you use the change of origin and change of scale, the same can be used in these cases. So I will find the moment about some other value, and using a relation between the moments about mean and moment about an arbitrary value, we will get this. Okay. So I'll look at the properties of the central moments.
So here a is always the assumed mean, or it can be anything.
It can be any number. We are calling it assumed mean, but it can be any number. So moment I am calculating about any number, whichever I feel okay.
So that number can be outside the date also.
Yes, yes, of course. But generally or practically, it is not good taking some value outside the data, but still it will work. There's no problem at all.
Okay. Sir.
Fine. Yes. So we'll discuss the properties now. I hope you're done writing this. Properties of central moments. What do you think of change of origin? Are you getting my point? Like what I'm asking? What I'm asking is, so whenever data is given to you, say for an example, it is given x1, x2, x3, x4, x5. Now I can find out the central moment for this. I can find x bar and I will make xi minus x bar raised to 1, the first column, xi minus x bar raised to 2, the second column, xi minus x bar raised to 3, the third column, and xi minus x bar raised to 4, the fourth column. I will add all the entries. So we'll get the summations here, right? And then what I will do is I'll find mu1, mu2, mu3, and mu4. Now, sum 1, what he did is he defined u. So ui is equal to xi minus 5, say. Okay, this is the change of origin, right? And then he will get u1, u2, u3, u4, u5. Now u1, u2, u3, u4 and u5. Using this, he can make u1 minus u bar, ui minus u bar column, ui minus u bar square. He also made ui minus u bar cube. So using ui's, he will get mu1 of u, mu2 of u, similarly mu3 of u. What do you think could be happening? Mu1, this is mu1 of x, this is of x. So all these values are for x. What do you think could be relation between both of them? Mrunal, what do you think? Tatsat? Ritisha left. Apurva, again today you have the mic issue or what? Not able to speak. Aaron, what do you think? No one. Yes, Ritika, speak up.
Sir, there will be no change.
There will be no change. Exactly. So, why? Why so? Why there won't be any change?
Sir, because the difference remains same ultimately.
Sir, the 5 gets cancelled, maybe.
Okay. Yes, Aroshi, what you're saying?
Even after changing the origins, if we take the difference, it remains same ultimately.
Yeah,
Is what-
exactly. So, change of origin. So, central moments are independent of the change of origin. That is the conclusion. So, as she said, this difference xi minus x bar and ui minus u bar, both of them are going to be the same entries. Okay, because you are shifting all the entries by 5 units, so this difference is always going to be the same. So that's why the first property, and a very important one, is the central moments are independent of the change of origin. So I'll just write this down. Central moments are independent of change of origin. Second, change of scale.
So it is dependent.
It is dependent. What could be the relation?
So mu will be divided by or multiplied by 5.
Mu will be divided by
5.
height. Height,
Yes.
h
That is
is
how much the scale have been changed.
coefficient, scaling coefficient. Okay. Yes, it is actually right. So central moments depend upon the change of scale. Say I have the first one, say the variable x are given to us, and what I'm doing is I'm defining u as x minus a divided by h. So scaling coefficient is h, and using this u I'm finding, so mu r of x is equal to h raised to r into mu r of u. This is the relation. So if I want to find mu3 of variable x, and I have the third moment of u. So what I'm going to do, I'll take h raised to 3 into mu3 of u. This is how we are going to translate from, or we will get the third moment of x from the third moment of u. Next one, the relation between moments about A and central moment. So mu r is equal to mu r of A minus r c1 mu r minus 1 of A into mu 1 of A plus rc2 mu r minus 2 of A into mu 1 of A square. Minus rc3 mu r minus 3 of A into mu 1 of A cube. So on. The last term will be minus 1 raised to r mu 1 of A raised to r. This formula looks a bit, complicated, but if you try to relate this with something, it will become very easy. So, what does it look like?
Binomial expansions.
It looks like
Binomial expansions.
exactly. So, it looks like binomial expansion. What is the difference? So coefficients are the same, as you can see, RC1, RC2 and so on. It will go up to RCR minus 1 and RCR will become 1, of course. So
Sir,
the B term is actually mu 1 of A, right? Yes, Saurav, what you want to ask?
sir, means for the third property, relation between moments about A and the central moments. So do we have to remember that for mu r we need to use a binomial expansion?
No, you don't have to remember that. I'm giving you the way by which you can derive the formulas whenever required. Okay.
Yes, yes.
So, as Manas said, it looks like binomial expansion where the coefficients are the binomial coefficients. Okay. So, and what is happening? Mu r, and it is going on decreasing. You have mu r of A, mu r minus 1 of A, then you have mu r minus 2, and so on. And what is happening? The other one, as I said, the value B is actually mu 1 of A. So mu 1 of A is there, then mu 1 of A square is there, mu 1 of A cube is there, and it goes up to mu 1 of A raised to R. So this is how we can actually remember. So mu 1, we always know that it is 0. What will be the formula for mu 2? Mu 2 is going to be, use the above formula. What I said, start with mu 2 of A minus, what is 2C1? 2C1 is 2. Then mu 1 of A into mu 1 of A. The next term is going to be plus 2C2. 2C2 is 1, and we will have mu 2 minus 2, mu 0 of A. So that is actually 1. So we'll remove this, and what we get is mu 1 of A square. So we can simplify this and we'll get a relation between mu2, the central moment, and the moment about A. So mu2 of A minus mu1 of A square, right? Can someone try for mu3?
So first term will be, I guess, mu3 of A
Mu3 of A
minus 2 in, no, not 2.
Okay, do it on a rough page and tell me the final answer.
Okay, sir.
Once you relate it with binomial expansion, it will become very much easier.
Sir, can I try?
Yes, Sasnan, please try.
Sir, mu3a minus mu3b. Where was it? Mu3b. Like, it's just basically a minus
No.
whole cube.
Do it on a rough page and tell me.
Yes.
Who has done it can tell the final answer. Ritisha, you have done it? Offline. Pratham Kaude.
No, sir, I'm doing it. I'm trying.
Okay, try. Param, Mayur. Palak Kaushik. Manas.
It's almost.
Sakshi.
Sir, just solving it.
Okay, tell me, Manas. So mu3 of A minus 3 times mu2 of A into mu1 of A. The next term will be plus 3 mu1 of A into mu1 of A square. And the last term will be minus mu1 of A cube. I hope you have got this.
I got just similar.
Yeah. So the simplification of last two term is always to be done because you get mu1 of A and mu1 of A square. So that will be actually mu1 of A cube. So the formula will be mu3 of A minus 3 mu2 of A into mu1 of A plus 2 times mu1 of A cube. Before I go for that, can someone tell me what is A plus B cube? Not someone, wait, let me call out the name. Latasha?
Sir, I had a doubt.
Just a minute, Saurabh, just a minute. Latasha? And look, I told you I have to give 100 marks as a CCA, so it is very important for me to judge students.
Yes, can you tell me A plus B cube?
A plus B whole cube minus 3AB into A plus B.
No. Okay, no problem. Mrunal? Nishtha? Sahil Jain. Okay, Vaibhav, please tell me.
So a cube plus b cube plus 3ab bracket a plus b
A cube plus B cube
plus 3ab
plus
bracket
3AB, which if you simplify will be 3A square plus 3AB square.
yes sir.
So, yes, thank you, Vaibhav. So you can observe that the formula that you got after expanding the previous one is actually the some similar to what we have got in terms of moments. Okay, so this formula, you can see that 3 is there, 3 is there. So if I make it a minus b cube, if this is a minus b cube, then this will become minus, will be plus, and the last one will be minus. So you can relate this formula with this, and you get the similar kind of thing. Okay, so this is how you can actually remember always. Now I expect the last formula from your side before we stop for this session is mu4. I need the final simplified. Saurav, what was the problem? Now you can ask.
Sir, in that mu3 formula, what is after 3 mu1a into u1a bracket square minus what is that?
Minus mu1a cube.
Mu1a cube. Okay.
Yes, who can tell
Sir
me
means
the?
sir
Yeah.
means to find mu1, whether it is mu1, mu2, or mu3, we just need to use the third property, right? So that we can get all those terms.
Yes. Yes, the last one, mu4. Who can tell me? I need the final simplified formula.
mu4 of A
Just
minus
mu4 of A
minus 4 mu3 of A into mu1 of A
mu3 of A into mu1 of A
plus 6 mu2 of A into mu1 of A whole square
mu2 of A into mu1 of A whole square
minus 3 into mu1 of A whole cube.
minus 3 into mu1 of A whole
Cube. Sorry, 4.
sure.
Raised
Very good. So only this fours are important. 4 formulas are important. Very good. That's all about the moments. So we will solve some examples in the Monday lecture, and we'll end up with
Sir,
the
can you
first
show
unit.
mu4?
Just a minute. Tomorrow we have a lecture. Sorry. Yes. Tomorrow we have lecture. In tomorrow's lecture, we'll end the first unit, that is statistics. And then from Monday, we'll start with probability. Mark your attendance.